All right, so we are still talking about measurements. We've talked about a lot of different and important concepts with measurements, looking at accuracy and precision, and then looking at sig figs and remembering that from now on, we always need to think about sig figs in all of our numerical answers. We learned how to do scientific notation. That way we can sort of shorten down those really, really big numbers that we're going to be using. And today we are going to talk about converting between different measurements and units, which is something else important that we need to always keep in mind whenever we have a numerical answer. Units. Okay, so we need to know the difference between a number and a quantity. So a number is simply a free number floating around in space. If you just tell somebody a number, you're not giving them enough information. They're not necessarily going to know what you're talking about, okay? But a quantity is more specific and more determined. It is the number plus the unit, okay? So from now on, whenever you have a numerical answer, not only do you need to think about sig figs, you need to think about the unit. What are we measuring? Okay, and just like with sig figs, your unit is going to be part of your answer. So if you forget to write your unit or you write the wrong unit, you're going to lose a portion of your credit. Okay, not all of it, but once again, a lot of college professors, if you do not write your unit, you get the entire problem wrong. Even if all your math is right, and you set everything up right and you got the right number, but you didn't put the right unit, they'll count the whole problem wrong. I'm not going to do that to you, okay? But be aware that that happens. You're just going to lose a little piece of your points, but you can still do well, okay? So sig figs, number, unit, okay? Units matter. Units matter. All right, so what kinds of units are we going to be using? We're going to be using the International Scientific System, okay? So if we are measuring length in any type of equation, length is going to be represented by the letter L. Your base unit is a meter, okay? Your base unit is a meter, which is abbreviated the letter M, the lowercase letter m. Okay. What about if we are measuring mass, for example? Mass is going to be represented in equations by the lowercase letter m. That's in the equation. Our base unit there for chemists is a kilogram. Okay. That can go smaller, right, to the gram. But most things are going to be measured in kilograms. So that's kg as your unit abbreviation. What if we're measuring time? We're going to want to measure that in seconds. And the letter T represents time in equations. Temperature, represented by a capital T in equations. We are going to learn about a temperature measurement called Kelvin. So I know you guys have heard about the Fahrenheit scale. That's what we use here in America. You've heard about the Celsius scale. That's pretty much what everybody else in the world uses. But scientists are going to use the Kelvin scale. So we'll learn about that later in the semester. If you're doing an amount, the symbol is an N, a lowercase n, and that measurement is called a mole, and that is a measurement that we will learn about coming up in the semester. Okay? Now, the great thing about using SI measurements is that they are very, very easy to convert between one and the other. Okay? So you have your base unit. So here your base unit could be, if you're measuring mass, it could be the gram. If you're measuring distance, it could be the meter. That's your base unit. Okay, and then as you move away from the base unit, you simply move the decimal place. Okay, and this tells you how many places you move. So let's say we're going smaller. So if we start at a gram and we go smaller to the decigram, you just move your decimal one place. Go down again to the centigram. Now you've had to go 2 places. Okay, milligram 3 places. Same in the other direction. Let's see if you're going bigger. So if you're going from a gram upwards, now this chart I originally put in here left out 2 spots. As you can see, the 1 and the 2 are missing. So if you're copying this into your notebook, make sure you add above the base unit, a gram would be a deca. a decagram, so that would be DAG, a hectogram, HG, then the kilogram, kg. Okay, so do copy this into your notebook, and we will get some practice using this. Okay. Now, I've told you guys before, I'm a visual person, so I like something that is a little bit more visually helpful to me. So let's put this in another format. I like to use it as a stair step. Okay, the reason I do it as a stair step is because it gives it a little more direction. These up here are higher up, that means they're bigger. These down here are lower, that means they're smaller. And now you get your direction left to right a little bit too, which helps you move the decimal, or helps me move the decimal. Okay, so for example, let's say we want to convert. Let's say that I am told that something is 5,670 centimeters, but I need that to be in kilometers. That's what I need it in. How do we convert this? How do we change it? It's great. We just move our decimal. So right now, our decimal is understood to be at the end, right? We talked about that with sig figs. The decimal is understood to be at the end. And with scientific notation, we're basically doing the same thing we did with scientific notation by moving that decimal place, okay? So our starting place is centimeters. So right here on our stair step is centimeters. That's our starting place. Where are we ending? At the very top of this particular example, at kilometers, okay? So if I'm starting here, how many steps do I move my decimal place? Well, let's see. I'm going to start here and I'm going to go 1, 2, 3, 4, 5 places to the left. So that's what I'm going to do with my decimal. I'm going to move it 5 places to the left. So if it's here, we're going to move it 1, 2, 3, 4, and 5. That last step I'm going to fill in with a 0. So it becomes 0.0567. Okay? Now notice I didn't write that last 0. Why not? Why didn't I write that last 0 in? Why didn't I keep it? Hopefully you guys said because of sig figs, because that would have been right. Because if we look at our original number, I have 3 sig figs. This last 0 doesn't count because there's no decimal. So 3 sig figs. So when I rewrote it, I needed 3 sig figs. Okay? Those beginning zeros don't count. 1, 2, 3. If I had written that last 0, that would have turned this into 4 sig figs. So that would have made that wrong. Okay? Because that trailing 0 would have counted since there was a decimal. Okay? Now, as we do calculations, when we divide or multiply, we can have what's called derived units. This is a combination of the base units that we get by multiplying and dividing. Okay, so for example, volume is a derived unit because you get volume by calculating length times length times length. So you get length cubed. So we're going to measure in meters, so meters cubed. Now in this orange box or yellow box right here is a super important conversion. I would write this on my chart that I have right in the beginning of my notebook, my equation page. Write it on there. This is super important. 1 centimeter cubed is equal to 1 milliliter, always. Okay, so that's super important. So if you need to convert between centimeters cubed and milliliters, it's a direct conversion. So I would definitely write that on my equation sheet. Another example of a derived unit is density. Okay, density is mass per volume. So it's a mass divided by volume. So here's our second equation that we can add to our equation sheet. Density equals mass divided by volume. Okay, mass divided by volume. Now the cool thing about density is if we are measuring density, we have to measure mass and we have to measure volume. We can put that on a graph. So if you put mass on the y and volume on the x, your slope will equal your density, which is really cool. Okay. All right, let's talk about how are we going to solve problems throughout the class. Okay, well, step 1, we need to analyze the problem. What information has been given to us? Then we need to plan. Okay, based on the information I have, what equation do I need to use, because as we go on, we're going to start having a lot of equations. So plan out, what equation do I need to use? Then we actually compute. We actually work the problem. And finally, we're going to evaluate our answer. Okay, we're not going to just trust that the answer is right. We got to take a look. Does this look like a right answer? Was I expecting a really, really big number and I got a really, really big number? That's good. Was I expecting a really, really big number but I got a really tiny number? Maybe I did something wrong. Maybe I need to rework. Okay, so evaluate. And in that evaluation, look at your sig figs. Look at your units. Do you have the correct sig figs? Do you have the correct units? Let's do some practice density problems with our new density equation we just got. All right, here's our problem. An object has a volume of 825 centimeters cubed and a density of 13.6 grams per centimeters cubed. Find its mass. Okay, so let's analyze this. What information have I been given? So right at the beginning, I was given a volume. So volume V equals 825 centimeters cubed. I'm going to write down my unit because I need to keep up with my units. Okay, what else was I given? Oh, I was given a density is 13.6 grams per centimeters cubed. And what was I asked to find? I was asked to find my mass. Okay, so now let's plan. What equation am I going to use? Okay, I have a density, I have a volume, I have a mass. That's everything I need for the density equation. I know this sounds silly right now because I just said we were going to use our density equation, but soon we'll have lots of equations. So I'm just walking us through that process, modeling those steps. Okay, so let's plan. What am I going to do? Well, I'm going to use my density equation. Okay, but the density equation is D equals, but I need M. I need it to be M equals. So you guys have all taken algebra by now, so you should know how to rearrange a problem. But what's cool about this equation is you can use what's called a triangle method, and I love it. So density equals mass divided by volume. So if you write it in a triangle with mass here, volume here, density here, then you can take what you need and see what's left over. So if you have density, you have to do mass divided by volume. If you have mass, you have to do density times volume because they're side by side. If you need to know your volume, then it would be mass divided by density. It's what's left. It's really cool. If you like that, but it doesn't really make sense to you, you want some more time talking with it, get into contact with me. We'll talk it over. Okay? But I need to know mass. So if I know my mass, what's left? Density times volume. Okay, so now let's work the problem. Let's just plug in the numbers I know. Density is 13.6 grams per centimeters cubed times volume 825. Okay, now let's go ahead and start keeping up with our units to make sure our units are doing what they're supposed to do. So when you have a slash, remember that means the centimeters cubed is like on the bottom of a fraction. So that means that I have a centimeters cubed on the bottom of a fraction. I have a centimeters cubed alone, that means it's on top. They can cancel each other out. So what am I left with? Grams. What kind of answer am I looking for? I'm looking for mass. Oh, and mass is grams, so that's good. Okay, then I just calculate this. 13.6 times 825, pop that into my calculator, 11,200 grams. Okay, notice my answer, I rounded that. When you type this in your calculator, you're going to get a lot more numbers. But I rounded it because my sig figs, this number has 3, this number has 3, so my answer should only have 3. Okay, one more. Okay, let's figure out what do I know. I know a density. I know a grams, that's my mass, so I have a mass. What am I looking for? What is the volume? Looking for volume. Okay, going to use that triangle again and say this time I need to know what is the volume. So if I know volume, what's left? Mass divided by density. Plug it in. 25 grams divided by 0.87 grams per milliliter. My grams cancel out, and because I have one on top, one on the bottom. And my milliliters are left. And my volume should be in milliliters, so perfect. So 29 milliliters because I need 2 sig figs. Okay? If you need some help, get into contact with me.